This video is going to explain how to solve radical equations. Here are the steps. First of all, you isolate the radical, and then you raise both sides to the appropriate power. We'll talk about that in a second. Solve the resulting equation, and then check for extraneous solutions. And I've done several examples so you can sort of get an idea of how these steps fit together. The first example is a very simple example. It says solve for x, and you see the problem. The first step in this process is to isolate the radical because the variable is underneath the radical. And remember, when we're isolating something, we do that in reverse PEMDAS order. So we'll undo any addition or subtraction first. And then we'll undo any multiplication or division. And now the radical is isolated. So now we're going to raise both sides to the appropriate power. Now this is a square root, so in order to undo a square root, we're going to square both sides. When I square the square root goes away, and when I square 3, I get 9. So now it's solved the resulting equation, and I do that by adding 2 to both sides, and that would give me 11. And then I check for extraneous solutions, and I do that by making sure that when I plug this back in, it actually works. So when I plug 11 in for x, I get 3 plus 4 times the square root of 11 minus 2. 11 minus 2 is 9. Square root of 9 is 3. So 3 plus 4 times 3, which is 3 plus 12, is indeed 15. So that works. So that's a solution. Next problem, very similar, but this time, instead of being a square root, we have a cube root. Process starts off the same. Isolate the radical. And then, still isolating the radical. Raise both sides to the appropriate power, and in this case, that would be a third power because we have a cube root that undoes the radical. And then solve the resulting equation. And then check for extraneous solutions. We'll check to see if it's extraneous. So that's 5 minus 7 times the cube root of 2 times 13, which is 26, plus 1. That's 27. Cube root of 27 is 3. So this is 5 minus 7 times 3, which is 5 minus 21. That is indeed negative 16. So that works. Now, the next example is going to be a little more difficult. And the reason it's more difficult is because we have 2 radicals in it. And the first step in this process is to isolate the radical. Well, when you have more than one radical, you can't isolate like both radicals at the same time. So basically what we do is the next best thing. We choose one of the radicals, doesn't matter which one, and we get it on a side by itself. So I'm going to get the square root of x plus 2 by itself. And I'm going to do that by subtracting the other square root. Now that radical is by itself, so I can go to the next step where it's to raise both sides to the appropriate power. Well, when I do that, I have to be mindful that when I square this side, I have to square the other side. And when I square the other side, that means squaring the entire quantity, not just anything individually. There's a minus in there, so I have to square the entire quantity. The left-hand side's easy. That would give me x plus 2. But the right-hand side actually requires me to think about this as foiling out. You're squaring a quantity that has an addition or subtraction in it, so that is a foiling process. So 5 times 5 is 25. You have 5 times the negative square root, and the same 5 times that negative square root, so that's negative 10 of that square root. And then negative square root times the negative of the same square root would give me positive the stuff that's inside. Now, this may look more complicated, but really it's better because what we started with had 2 radicals in it. Now this only has 1. So now I can actually loop back to the beginning of the process and work to isolate this radical. So what I'm going to do is I'm going to combine like terms first. So I have a 25 and a negative 3, so that's 22. And then I have this x sitting here. And the rest of it. And now I work on isolating this radical. So I'm going to subtract x from both sides. I'm going to subtract 22 from both sides. Those go away. That's awfully nice. So that gives me this. Divide by -10. Square both sides, since this is a square root. And then add 3 to both sides to solve. And then check for extraneous solutions. So when I plug the 7 in, 7 plus 2 is 9, square root of 9 is 3. And then 7 minus 3 is 4, square root of 4 is 2, 3 plus 2 is indeed 5. So this is in solution. So whenever you have two radicals, isolate one of them, square root of both sides, don't forget to FOIL, and then work to isolate the remaining radical. So the last example is similar to this one, but slightly more complicated, and you'll see. I'm going to do this the same way I did the last one, so I'm going to isolate one of the radicals. I'm going to square both sides, remembering to square the entire side on the right. When I square just the radical on the left, that would give me 2x plus 1. When I square the quantity on the right, that would give me 4 plus 4 square roots of x minus 3 plus x minus 3. And if you wanted to show the FOILing work for that, you can. I just know that what the pattern is for a perfect square, as I should do, but if you don't remember it, that's fine too. So now I have one type of radical, so I'm going to work to combine like terms and then isolate that. So when oops, I left my x off there. Just add it at the end. So now I'm going to isolate. Let's see, that goes away. That's nice. So I get this. Now don't let the fact that there are x's on the inside and outside of this radical throw you. I'm still going to follow the same procedure. I'm going to isolate the radical. Now, before I do that, I could isolate the radical here, and that would be okay. I would just have a fraction to deal with. I could conceivably square this at this step, as long as I remember that when I square this side, I have to square the 4 and the square root. So the 4 would become 16, and the square root would go away. So now this is a quadratic instead of what we had before, which were all linears. So I'm going to solve this like a quadratic. I'm going to distribute that 16 and then get everything onto the same side. So now I'm looking for two numbers that multiply to give me -16 and add to give me 48. This does actually factor. Sometimes if it didn't factor, I might have to use the quadratic formula to solve for x. So this gives me two answers, 12 and 4. So now I need to do my last step, which is check for extraneous solutions. So when I check 12, I get 2 times 12, which is 24, plus 1, which is 25. Square root of 25 is 5. And then 12 minus 3 is 9. Square root of 9 is 3. So 5 minus 3 is 2. That one checks out. When I check 4, I get 2 times 4, which is 8, plus 1, which is 9. Square root of 9 is 3. And then 4 minus 3 is 1. Square root of 1 is 1. So 3 minus 1, 2 as well. So both of these work. Now, occasionally, when you do this, you'll get one solution that works, one solution that doesn't. When it does, any solution that works you're good with, anyone that doesn't is extraneous. You mark it out.